number 5, we have y equals e to the 2x and y equals 3 and x equals -2. Okay, and then the area bounded by these curves, these functions, would be this part. And then you're revolving around the line y equals 1, x equals 1, so that would be right here. Right, and then you would be getting something like and as you can see, there is a hollow space in the middle again, right? But then this is not hollow, this is all shaded. Okay, and the functions are in terms of y equals, while the line of revolution is in terms of x equals. So we're going to use cylindrical shells. Okay, so v equals 2 pi from, which ones? 2 pi, -2, 2. Oh, and then we have to find the actual upper intersection again. 0.549. Okay, so since our function right here is before our line of revolution, which is x equals to 1, right? It's to the left of it. The function is the left of the line of revolution. So that's why instead of just saying x as our radius, we're going to say x. So 1 minus x. And then we're going to say the height, right? Because this side is going to be radius, so our height is going to be perpendicular. So we're going to say y equals 3. 3 minus e to the 2x. And then dx would be our answer. We have these two functions, and then this is from 1 to 1.5. Okay. So it's going to be this whole 0 to 1.5. This whole area right here. But something that we forgot is that we have a boundary line right here, right? It's labeled, but it's labeled in black, so it's a little bit hard to see. Okay, so that's what we have, and then we're revolving this around the x-axis. So ultimately, we're gonna get a shape like this, but like obviously, a little bit longer than this. But my screen is too short. So something like this, and as you can see, there is no hollow space in between, so we're gonna be using the disk method. This is gonna be y equals 0, right? And then we're gonna say v equals pi times. What we do is that we divide this into 2 parts. Okay. So it's like from the intersection. Before the intersection, the green function doesn't really affect the area or like the volume, right? Because our shaded area is on the line. So we're gonna say 0.526, and this is only recording the line right here, so x plus 3. Okay, and then this whole thing squared, dx, right? And then what we're gonna do is plus pi and then 0.526, and then it's going to end up here, right? So from 0.526 to whatever this point is, the purple function doesn't affect the area or the volume and area because it's only under the green function, so we have to do this separately. Okay, so let's see when the green function has a 0. And then we're going to do cotangent x squared to the power of 2 dx. Okay, so this will be our answer. And then number 7. So y equals x, and this is revolved around y equals -2. So we're not using cylindrical shells for sure. And then this is the area bounded, and then we're revolving this around this line. Right, so there obviously is a hollow space. It's gonna look a little bit like this. a little butterfly and a hollow space in the middle. Okay. Alright, so we're going to be using the washer method. V equals 0 to 3. Right, and then the outer function is going to be the red function. So, and since the red function is on top of the line of revolution, we're going to do x plus 2 to the power of 2, right, pi, and then minus x times x minus 2, and then plus 2, right, because it's still on top of the line of revolution, to the power of 2, and then just dx. Alright, so for number 8, it says that we have these two functions, and then those two, the area bounded by those two curves are being revolved around the line x equals to 2. So the x equals to 2 is not identified on the graph right here, but then we can kind of draw an imaginary version of it. So let's see. This is the area bounded, right? And then it's going to be revolved around a certain line, like right here. Alright, and then what we're going to do is that we're going to revolve this. So we have a little hollow space in the middle. Okay, I can't draw the full version of it because we don't have a lot of space, but then it's essentially going to look like this. So it's more like a spacecraft kind of shape. And then this is also going to be the shaded area. And then the hollow area is in the middle. Alright, so this is the shape that we're looking at. And then let's see which method we should use. So obviously we see that this is in terms of y equals, and then this, the line of revolution, is in terms of x equals. So we're going to be using cylindrical shells method. Okay, and then so v equals 2 pi integral of from this point to this point, right? So we got these for our upper limits of integration. So these are the intersection points of two functions. And then this is going to be our line of revolution right here. So since the functions are to the left of the line of revolution, we're going to say 2 minus x, right? Right, this is going to be our radius. And then our height is going to be the purple function minus the green function, right? So it's going to be ln x ln x plus 1 minus x third, and then minus 3x plus 2. So this whole thing right here is going to be our height, and this is going to be our radius, so dx. So this would be